Good day everyone, welcome to another tutorial by Smart Kites. In this tutorial we are going to solve a question on the Bernoulli's or energy equation, where the question states a closed tank has an orifice of 0.04 diameter. The tank is filled with oil of specific gravity of 0.9 to depth of 2.5 meters over the center of the orifice. The airspace is pressurized to 150 kilonewton per meter squared. If the coefficient of discharge is 0.62, we are to find the discharge from the orifice, given that the atmospheric pressure is 101 kilonewton per meter squared. Before we start solving this question, I would like you to kindly check under the video. You'll see one red button written subscribe on it. Click it, then subscribe to the channel and click on the bell icon so that you'll be notified when we solve any more questions and upload on this channel. So now the solution. So here is the diagrammatic view of the problem. Now let's bring out the data from the question. We are given the diameter D to be 0.04 meters. We are then given the specific gravity of the oil, to be 0.9. We are then given the height, which is the distance, let me call it height for now, to be 2.5 meters. We are then given the pressure there up where I wrote 1, which is 150 kilonewton per meter squared. Then we are given the coefficient of discharge to be 0.62. We are then told to find the discharge, which is Q, given that the atmospheric pressure PATM is 101 kilonewton per meter squared. Now let's bring our Bernoulli's equation. Our Bernoulli's equation is P1 over rho G plus V1 squared over 2G plus Z1 is equal to P2 over rho G plus V2 squared all over 2G plus Z2. Now back to the diagram. If you can see the orifice part where the water is coming out of the orifice, that's where I have my 2, that's the outlet, and there top where I have the pressure of 150 kilonewton per meter squared, I have 1. Therefore, that's the inlet, or that's the part 1, and where I have the orifice, that's the part 2. So at the part 1, the liquid have no velocity, it's not moving, so I can directly say my V1 is 0. So since V1 is 0, from this my equation, I can say V1 square, that's 0 square over 2G, everything here now becomes 0. Also, for the other part, if you can check the diagram, this height, that's 2.5, that's the height from the top where the inlet is. But for the outlet, the height where the orifice is almost at 0 from the ground, at 0 level, or at almost 0 level. So I don't have the second height or the height of the output. Therefore, Z2 can be said to be 0. Since Z2 is also 0, I can also do it like this from this equation. Z2 is 0. Now, what am I left with in my equation? What I'm left with in my Bernoulli's equation is P1 over rho G plus Z1 is equal to P2 over rho G plus V2 squared over 2G. What I'm going to find is the discharge, and when finding discharge, I have to use the velocity of the fluid. Since I'm looking for the discharge at the output, so I will have to find the velocity of the output. If you can see, I have the pressure 1, I have pressure 2, all from the question. I know my G is constant, and I also have Z1, which is the height given. What I don't have is the density, that's rho. I'm given the specific gravity of the oil. So we know that specific gravity of any substance is equal to the density of that substance over the density of water. Density of water, which is 1000 kilogram per meter cube. So for the oil now, the density of the oil will now be said to be the specific gravity of the oil, which is given from the question, times the density of water, which is known to be 1000 kilogram per meter cube. So density of the oil is now 0.9 times 1000, which is equal to 900 kilogram per meter cube. So now I can find the velocity at the outlet from the equation. Now let me change the equation into another form, like just rearrange it. I can now say Z1 is equal to P2 minus P1 over rho G, then plus V2 squared over 2G. I have everything excluding V2. So now 2.5 is equal to 101 minus 150. If you recall, the unit is kilonewton per meter square. In kilo, that's 10 to the power of 3 over the density of the oil I just calculated to be 900, and the gravity is 9.81 gravitational force, is plus V2 squared, V2 I don't know it, that's what I'm looking for, over 2 times 9.81. So now 2.5 is equal to, if you calculate this right in your calculator, you'll see that it's minus 5.55 plus V2 squared over 19.62. Therefore, 2.5 plus 5.55, 8.05 is equal to V2 squared over 19.62. V2 will now be the square root of 8.05 times 19.62, which is equivalent to 12.57 meter per second. This is the velocity of the oil at the output. What the question wants me to find is the discharge. So for the discharge through orifice, the formula is known to be Q is equal to CD, that's the coefficient of discharge, times the area times the velocity. I have the velocity, which is what I calculate. I also have the coefficient of discharge from the question, but for the area, the question gave me the diameter of the tank, which is 0.04 meters. So now the discharge will be then CD times what's the area, pi d square over 4, then times the velocity, which I have everything now. I'll say Q is equal to 0.62 times pi into 0.04 squared over 4 times the velocity 12.57. Inserting this in your calculator, you'll see that the Q, the discharge, will be equal to 9.79 times 10 to the power of minus 3 meter cube per second. This is the discharge of the oil through the orifice. I hope you enjoy and understand this video. If you have any question or misunderstanding, kindly drop it in the comment section, as I will always be there to answer your questions. Hope you learn a lot. Kindly subscribe to this channel and come back for our next video. See you later.